Yeah, question 3. Evaluate the following with respect to x. Okay, and we have the integral. We have this integral. We have the question here. So let's go straight to the solution to that. Solution to that will be, we have integral over 2x over x plus 6 times x minus 1. Okay, dx. And then we have the upper boundary of 3 and 2. So what we do in this case, without wasting time, the denominator has been given in a linear form, in a linear factor. Okay, that's one. And then two is that the power of the denominator is higher than what? Than the numerator. Okay, so in that case now, that will just take us straight to partial fraction. Okay, and in this channel, we have a series of videos on partial fraction. Okay, we have a series of questions on a series of videos on integrations that involve a partial fraction. Please check it out on the channel. Let's take the fraction out. 2x, x plus 6 times x minus 1. Okay? Partial fraction is a linear factor, and that will be a over one of the linear factor. And second linear factor, that will be what? Another constant, b over x minus 1. So we have resolved it into what? Into partial fraction. So then the next thing to do now is to multiply through by the common factor, which is x plus 6 times x minus 1. So this side, each item, the right hand side times the common factor. So the denominator we cancel the moment you multiply by the common factor. So you have 2x on the right hand side. Here also times the common factor. X plus 6 is here, x plus 6 is here. So if you cancel out, you have what? A times what? X minus 1. Then plus b times x minus 1 is 0, x minus 1 is 0. So that cancel out. So we have x plus 6. Okay. And the faster way is just to cross multiply this one times this one. Okay. And then this one times this one. Okay. So that's what we've gotten now. Then the next thing to do, our goal is to get the value of A and the value of B. So how do we do that? What we are going to do is that we are going to find a way of cancelling certain expression here so that we can get the other words. We can get the constants. If we can cancel s, if s minus 1 can turn to 0, then we can get the other words, we can get the b, the constant. We can get the b. So let's substitute. Let s equal to 1 here so that a we cancel, we can get b. So and that will be equal to what? 2 times 1 equal to 1 minus 1 times a. That one cancel. Then we have b into brackets 1 plus 6, that's 7. So b is what? B is 2 over 7. Okay. Let's also repeat the process also. Let's cancel the expression s plus 6. And that can be cancelled by using let x be what? Minus 6. So if you do that, then you can get the a value. And that will be what? 2 times minus 6 equal to what? Equal to a into bracket minus 6 minus 1. That's what? Minus 12 equal to what? Minus 7a. Okay? So minus can cancel out, can cancel each other. Then we can get the a as what? 12 over 7. So we've gotten the a and b. Then that can take us back to the question. Integral from 2x over x plus 6 into bracket x minus 1 dx is equal to, my a is what? My a is, that will be integral. So open your brackets. My a is 12 over 7. 12 over 7 over x plus 6. Then plus b is what? My b is 2 over 7 over x minus 1. Close your bracket and put your dx there. Okay. Then the implications of this implies, this one here implies integral of what? You can take your 12 over 7 outside, 12 over 7 outside, and that's what? Integral of 1 over x plus 6 dx. Then plus what? 2 over 7 also here can be taken outside, 2 over 7, integral of what? 1 over what? X minus 1 dx. Okay, because when you have integral of sum of functions, it will be integral of each of those functions. Okay. So that's our question. So we have what? 12 over 7, integral of 1 over x plus 6 dx, then plus the second one, that's 2 over 7, integral of what? 1 over what? X minus 1 dx. Okay? So 3 over 2, 3 over 2, 3 over 2, 3 over 2. Okay? Then that will be equal to what? 12 over 7. Integral of this one will be what? ln x plus 6. You can put your upper boundary and lower boundary. Then plus the second one, you have 2 over 7. Integral of 1 over x minus 1. That's the ln x minus 1. Then put your upper boundary 3, 2. Okay? And don't forget, when you have integral of 1 over x dx, don't forget it's what? ln x from the table. Okay? Why? Because whenever you have the derivative of the denominator equal to what? Numerator, it will generate what? ln of that denominator. So there is in addition, if you are adding either a constant plus or minus to that variable, okay, it still become ln what? Ln x plus what? Plus or minus 2. Okay, because if you check this one now, the derivative of x plus 2 is 1 also, which is equal to what? Numerator. And when that happens, it will be what? It will be ln, okay, of the what? Of the denominator. So that's that on that. That's 12 over 7. That will be ln 3 plus 6, that's 9, and minus what? Ln what? Ln 8. So I'm through with this now. I'm through with this. Then the second one, plus 2 over 7, ln 3 minus 1, that's ln 2. Then minus the lower boundary, that's 2 over 7. Let's just close it this way. Ln 2 minus 1, that's ln 1. 2 minus 1, that's ln 1. ln 1 is 0, so this one is cancelled out. 0. So we now have 12 over 7 ln 9 minus 12 over 7 ln 8 and plus 2 over 7 ln 2. So that's the answer. I just want to do efficiency, and we can do that. 1 over 7 is there, 7 is there, 7 is there. Take it outside. 1 over 7 and open your bracket. 12 ln 9 followed by plus 2 ln 2, then minus 12 ln 8. So we now have 1 over 7, open bracket, write a common logarithm, and that will be what? 9 to the power 12. This 12 will come to here, and then this one also will be 2. This 2 will come to top here. That's 2 to the power 2 times 2 to the power 2 all over 8 to the power 12. Okay, but the question says we should leave our answer in 2 decimal places. The question says we should leave our answer in 2 decimal places. So we need a value for that. So that's giving me 0.39955. So 2 decimal places, that will be 0.40. Yeah, question 4. Integrate the following with respect to x. We have the lesson solution to that solution. The first thing we can do, we can take these 2 outside the integration. That will be 2 integral of what? ln this. Okay. So what we can do here we are going to use integration because there is no direct table for ln x. So we're going to use integration by parts, whereby my u will be what? ln x. And the v will be what? dx. Why is my u being ln x? Is because it's differentiable and it becomes simpler on differentiation. Okay, so and it's ln x is not, you can't integrate it. Okay, so that's that. So then get your du dx. So du dx will be what? 1 over what? 1 over x. So du is equal to what? Du is equal to 1 over x dx. Then can you integrate this one? V will be equal to what? X. So integrate both sides. So we have v equal to x. Then I'm using this formula uv minus the integral of v and du. That's what I'm using. So my uv is what? This is my uv, which is what? X ln x. And don't forget the 2 outside. So the 2 outside, don't forget your 2 outside. X ln x. Then minus v, integral of v. My v is what? X. And then the u is what? 1 over what? 1 over x dx. Okay? So this will cancel. This will cancel. So I just my final answer. I can open the bracket. That will be 2 times this one. That's 2x ln x. Then we just have this one here. Integral of the x is what? Is what? Is x times the 2 outside. That's what? That's minus what? Minus 2x plus what? Plus c. So that ends the question. And that's my answer to that question.